Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy. You know, one of the things that really interests me about the Flat Earth movement is some of the questions that they ask because they make me start to think back to my middle school, high school, and college education. One of these questions is, well, I can't feel the Earth moving under me. How can you prove to me that it's rotating? Now, I obviously like the rotating Earth. It's in the background right here, sped up over 700 times. So when Ranty Flat Earth and I spoke about appearing on his new series, he asked me to come up with a good idea for a video that I could present, and I decided to go ahead and show the demonstrations of how we can tell the Earth is rotating. So I hope you enjoy it. The first thing that I thought I would talk about would be sunrise and sunset, dusk and dawn. What evidence does this give us that we are on a rotating spherical Earth versus a flat stationary Earth with the sun moving overhead? Now let's start off with this photograph right here. This is we'll say it's a sunset. There's a couple of things that you can note with this. First, we're looking out over water. Second of all, the sun is halfway under the horizon. And third, the bottoms of the clouds are lit up. Now, demonstrating the exact same principle is this shot of Mount Rainier in Washington State in the United States. You can clearly see where the sun is in the mid portion of the photograph on the left. Mount Rainier is casting a shadow upward onto the base of the clouds above it, and of course the clouds are lit from the underside as well. Now, one thing that you will occasionally hear in the flat earth community about photographs like this is that this is merely the sun reflecting off of the surface. Well, in the first example, the sun would be reflecting off of water. In the second example, the sun is reflecting off of tree-covered hills. Obviously, the reflective index of water, snow and ice, tree-covered hills is different, yet we see the exact same effect. This is direct sunlight shining through the mountain and casting a shadow on the clouds, and it's direct sunlight illuminating the bottom sides of clouds. Now, another term that you will hear bandied about occasionally is perspective. This photograph is an excellent example of perspective. Here we have two stairways that have partial walls on either side of them, and then we have a brick space, and above that is a roof. If you were to imagine the sun being suspended from that roof and the clouds being at the top of those half walls, you can clearly see that at no time, due to perspective, would the sun ever appear to be below the clouds. So it's simply not a tenable excuse. Now, on a flat plane Earth, there is no conceivable way that the sun can appear above the clouds at noon, yet below the clouds at dawn and dusk, without multiple violations of geometry and perspective. However, it is easily explained on a curved Earth, whereas the sun, represented by the blue arrow, illuminates the bottom side of a cloud after sunset that is observed by someone in the dark side of the Earth looking upward in the direction of the red arrow towards the bottom of the clouds. So this mandates a curved surface of the Earth in the east-west direction, and either the Earth is rotating under a fixed sun, or the sun is following a circular orbit around a stationary but curved Earth. The pattern of light and shadows at sunrise and sunset confirms that the Earth is curved in the east-west direction and it rotates relative to the sky. Now let's turn our attention to the heavens and address the matter of star trails, domes, and spheres. Now this is a panoramic photograph of the 24-hour sun at one of the poles. You can see where it dips down towards the horizon represents sunset and sunrise. And then as it reaches the highest point of that roller coaster, that would be noon. They are 12 hours apart. Now, our observations of the sun in the east and west directions suggested a curved surface of the Earth which was rotating relative to the position of the sun above it. Let's turn our attention 90 degrees to the north and have a look at the northern celestial pole. This is a shot from the northern hemisphere. You can see the star trails are rotating in a counterclockwise manner around Polaris, which is at the center of the circle there and is stationary. This could work on a flat, round Earth that was rotating about the North Star. However, we do have a problem. And that problem is the southern celestial pole, which is seen here. Notice that the star trails are moving in a clockwise direction, opposite what we see in the northern hemisphere, rotating about an empty space called Cygnus Octaris, which is the southern celestial pole. There is no rotational geometry that will allow a rotating flat Earth to create both a northern and a southern celestial pole. The fact that there is a north and a south celestial pole with the stars rotating around it, and that we cannot see Polaris from the southern hemisphere nor the Southern Cross from the northern hemisphere, confirms that the surface of the Earth curves in the north-south direction. Here's an illustration of the problem. If you have a round, flat Earth, as pictured here, with a dome over it, and you rotate that dome, you can reproduce the star trails we see over the northern hemisphere, centered about the North Star. However, if you were at any location in the southern hemisphere and you looked south, you would see exactly the same stars, even though you may be on opposite sides of that disk. That presents a major problem. Let's illustrate that problem with this short animation from Josh Lays, and then see how a north-south curve in the surface of the Earth and a spherical Earth elegantly solves it. Now, while a rotating spherical Earth elegantly solves this problem, let's go ahead and play devil's advocate and look at the possibility of a stationary spherical Earth and a stationary flat Earth. The only way that we could reproduce the movements of the Sun and the celestial poles along with a celestial equator would be to have a celestial sphere orbiting or rotating about the Earth, as illustrated here. Now let's turn our attention to the question of rotation and centrifugal force. Now let's imagine that we have a flat disc-like Earth, as pictured here, and we rotate it about the North Pole, much like a record on a record player. If we place a marble on the southern tip of Africa, that marble would move directly south and fall off the edge due to centrifugal force. We all did this as kids with a coin on a record. Now, as a side note, if we walked south, it would appear as though we were walking downhill, and if we walked north, we would feel like we were walking uphill. Okay, obviously we don't see that on Earth. So consider this situation. If we were living on the broad surface of this quarter, and it was rotating about an axis of, say, the prime meridian, we would lean east or west depending on where we were in relationship to the prime meridian. Again, we don't see that on Earth. But take a moment and consider this situation. We're on a spherical rotating Earth. Gravity is holding us down as we stand on the surface of this ball. However, centrifugal force is responding to the rotation, and it would oppose that gravity. So, the opposition would be greatest at the area of highest velocity, which would be the equator. The bottom line is, the closer you are to the equator, the less you would weigh. The closer you are to the North or the South Pole, the more you would weigh. I wonder if that's what we see on Earth. Let's check. Well, at 32 degrees south latitude in Perth, Australia, this object weighs 500 grams. Now, at 35 degrees south latitude, closer to the South Pole, this object weighs 500.16 grams. It weighs more. It is further away from the equator. Going back towards the equator to Broome, Australia, at 18 degrees south latitude, 499.44 grams. It weighs less. It is closer to the equator. This seems to confirm our suspicion of a rotating spherical Earth. This is exactly what we would expect from that. Well, guys, in the home stretch now. So what we have is this. Our evidence so far strongly suggests that we live on a rotating spherical Earth. But there's still one possibility that could keep the hope of the flat Earth alive, and that is if there was a rotating celestial sphere around us and the Earth itself was completely stationary. Let's see if we can find out if the Earth is moving or the sky is moving using gyroscopes. Well, everybody, let me introduce you to the laser ring gyroscope. This is a laser light interferometer working on the Segnac effect that can detect rotation in one axis. Here's the interesting thing about a laser ring gyro. It has no moving parts. It does not have any friction. It's highly accurate. It's used in the inertial reference system of commercial airliners. If you point this thing in the axis that it detects at the horizon in the east, and if the Earth is not moving, it will measure no rotation and stay right on the horizon. If you point it at the horizon and the Earth is indeed rotating 15 degrees per hour, which is what our 24-hour rotation would require of a spherical Earth, it will measure 15 degrees per hour of rotation. Let's let Bob Nodal from Globebuster tell you what happened when they tried this experiment.
One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15 degree per hour drift.
Well, I wonder why that is. So, Bob, your own test demonstrated that the Earth is rotating at 15 degrees per hour. You know, one of my favorite things about the flat Earth, they provide us with all the evidence we need to show that the Earth is indeed spherical. Thanks, guys. Well, now that we confirmed that it is the Earth that is rotating and not the celestial sphere, let's see if we can take advantage of that rotation. Now, unlike laser ring gyroscopes, mechanical gyroscopes undergo something called precession. Now, normally this is kind of an error, but we can take advantage of it in a device called a mechanical gyrocompass. And here is an example of a Sperry gyrocompass. These are marine compasses. They do not rely on the magnetic poles of the Earth to find true north. They use the rotation of the Earth and precess until they point to true north. It's been put in use on hundreds of thousands of ships in the last 110 years, 111 years. It finds true north every time from any location on Earth. This fact alone confirms that we are on a spherical, rotating planet. Well, guys, as I said, the mechanical gyrocompass alone proves that the Earth is a rotating sphere. Now, you combine that with the other evidence that I have just presented, and the case is incontrovertible. Now let's go ahead and review our conclusions here. Based on the pattern of light and shadows at sunrise and sunset, the Earth is curved in the east-west direction, and it is also rotating in relationship to the sky above. Whether it's the sky or the Earth rotating, we haven't determined yet. Number two, the Earth is curved in the north-south direction, and it rotates relative to the sky as well. Again, we don't know if it's the Earth rotating or the sky rotating. Given number 1 and 2, the only geometric shape that fits is that of a sphere. It is geometrically impossible for the Earth to be a flat plane with the stars and the sun rotating above it. Number 4, star trails can only appear as observed if the Earth is spherical and rotating, or there is a celestial sphere rotating about it that contains these heavenly bodies. Number 5, a laser ring gyro confirms that it is the Earth and not the sky that is rotating, and the Earth's rotation accounts for the entire 15 degrees of rotation that is observed when we look at the sky. And finally, a mechanical gyrocompass requires the Earth to be rotating in order to precess to true north, and this occurs at all locations on Earth and has done so for more than a century. Well, guys, that's about it. I think that I've laid out my case well for the rotation of the Earth and probably proved that it's spherical as well. Now the ball's in your court. This is quite a bit of evidence that you have to go over, and quite frankly, it's up to you in the Flat Earth community now to try and disprove me. You have the burden of proof. I've presented my evidence, now you get to present yours. Now, this particular video was done for Ranty Flat Earth. He has a new talk or debate show concerning issues in the Flat Earth on his channel, and I happened to notice it. It seems like it's a pretty good show, and it's basically adults talking to adults like adults. It's in sharp contrast to the Flat Earth debates that I've seen in the last 8 months, and I wanted to support it, which is why I'm here. So, I'm going to hang around, and I'm going to be in the live chat as soon as this presentation is done. I'm available to answer questions. However, I'm only going to answer questions on the material that I presented in this video. Now, I'm not going to answer all the questions, because if by your question I decide that you didn't pay attention to a point that was presented in this video, I'm going to refer you back to the video to watch it again. Now, if you really want to get a question through and you want to get my attention and get a response, how about tossing out a super chat for Mr. Ranty here? Now, none of this goes to me, it all goes to him, but I want to support his channel and support this type of dialogue between Flat Earth and Globe Earth. So show him a little bit of love, and I'll be sure to answer the question that you ask with it. So, signing out from Northern Michigan, this is Bob the Science Guy, and I'll see you in the chat in a couple minutes. Now, you do have quite a burden of proof to overcome, so may the odds be ever in your favor. Take care, guys.